This demonstration is about calculations involved in chi-square test. We know that in this case, we have to compute the expected frequencies, and we have to come up with this metric on the basis of data, and we will compare the chi-squared calculated value with the chi-squared value at some significance level with the degrees of freedom. And in this demonstration, I will apply this the calculation scheme for fitting a normal distribution to the data. So we have a frequency distribution of weights of 100 graduate students, and which are classified with the frequencies 5, 18, 42, 27, and 8. So with this information, weights of the student and the frequency, let's begin the calculations in Microsoft Excel sheet. I have the Microsoft Excel sheet open. So I paste the data over here, and let's reduce the font size. Okay, that's fine. Okay. So in the first column, we have weight of the students and weights of the students. Second column, class mark, which is the mid value of a particular class and the corresponding frequencies there. To apply the normal distribution model, we have to first evaluate the mean value and the standard deviation, because a normal distribution is defined about a mean value and a standard deviation. Um, I first attempt to write the formulas, equation that I am going to use in my calculation. So for mean value from group data, the mean value is represented by the symbol mu, and it is an expression of computation of summation. In the numerator, we have a summation of f times x summation notation. Okay. This one would be nice. So it is the frequency of a class times the class mark value in that particular class xk, where the k values run from 1 up to the number of classes, and divided by in the denominator we have a similar summation, but only on f of k. F, and here we have, well, of course, k varies from 1 up to n classes, and k varies, which is equal to the total number of observations. So this is the formula to compute the mean value. Seems very congested. Okay, then the calculation of standard deviation. The calculation of standard deviation it is represented by the Greek symbol sigma, and a short formulation for this one is based upon the square root. Oh, okay, this one. This is the square root. In the square root, we have a first the calculation f of a, the subscript f, and in the subscript k times xi squared x I and square of it. Okay, and it will be its average value. In the new style, I really feel difficult to write the expressions. Yeah. Okay. Yes, this is appropriate. X of k and square of it. Behind that, I require a summation notation. It's very difficult to select. Okay. Yeah, that's fine. Oh no. Okay. And with this, f k and the varies from 1 up to n class and divided by k varies from 1 and divided by the total number of observations. So let's write here n. This k is x. Okay. Okay, that's fine. And then I write here minus mu squared. Mu value and square of it. Square. But this should not be in the denominator, numerator. It should be somewhere here. Yes. But it should be within the square root. Yes. That's the correct way of writing it. So now I will implement this calculation to come up with the parameters. This expression would be used in the calculation of mu and sigma. So for that very purpose, I compute here f times x. So this is equal to the value of f times the value of x plus mark. And similarly, I will do these calculations for all the cells. Okay, this was extra. And here I define a total value the sum of frequencies can be defined with summation function in Excel. So it is applied to all the cells. So 100 is equal to the 100 students. And similarly here, summation would yield the summation of product f times x, and the calculation of mean now. The calculation of mean is mu value so mu value this value would be equal to the sum f of k x k and divided by the total frequency, so which is at C9 value. This is mean value, and for standard deviation I have to compute fkx k squared. So right here f times x times x, which means the f times x squared. So this will be equal to f value times x value times x value. So this is squared, and we require its summation. Sorry, a repetition of this calculation, and then summation is required. So the similar calculation is performed in column K. So if I see this one, so it is the summation in this column. And if I see this calculation, so it is based upon summation of values from K3 to K7. Okay. Then computation of variance. Variance. So variance would be equal to, variance is equal to the value computed as x f k times x k squared and divided by the total number, which is 100. I can select it from C9 minus the mu value squared. So we have the mu value in this cell. So I write here square of it, and then the sigma value, which is standard deviation. The sigma value from symbols, it can be properly chosen. So this is equal to square root of the variance value. So we have got all the computations on the basis of data. These are the required values, and now we can move on to develop the normal distribution, because the parameters are now available to us. In order to develop the normal distribution, we have to have the transform variable z. So for all classes, I define their lower limits. For this problem, it is equal to the value, the class mid value minus 1.5, because the class width is 3. And then similarly for the class upper limit, this will be equal to the class width mark plus 1.5. So for the rest of the classes, we can repeat the same pattern of calculations. And then correspondingly, let's define the z values. So the lower limit and the upper limit, this will be equal to the lower limit value, the lower limit value of the class minus the mu value. So I will pick it from its position. It's at k11 divided by the sigma value, and it is at k13. Similarly here, equal to the upper class limit minus the mu value 11, k11 divided by k $30. This is important. Now the lower and upper limits of all classes have been computed. They should be computed by repeating the same calculation. And now the probability in one class, probability in class. So I can use the normal distribution function, which is more precise than the normal distribution table available. So it will be the phi value or cumulative probability to the upper limit of the class minus the probability computed to the lower limit of the class. So for this case, we have the function. So I write here normal standard distribution. So upper limit, and we define the cumulative, which is an indicative of area under the normal distribution curve from minus infinity to the particular value of v. Similarly, minus, we compute the area up to the lower limit distribution. It is at n and 3, and true for cumulative distribution. So this will be the probability. So with these probability values, we are ready to compute the theoretical frequencies or the expected frequencies, which are based upon the normal distribution parameters computed from the data. So these are simply probability values times the total number of observations, which were 100. So to keep that one fixed in our self calculations in a column, I place a dollar sign so that it remain fixed when I repeat these calculation for the cells below. So we have got these values. So expected frequencies and the observed frequencies. So now for the time being, let's hide these cells. Well, these were written above the cells, therefore they have not been hidden. Okay. So now we have the expected and the observed frequencies. Okay. So now we observe that the expected frequency is less than 5 only in the first cell. So this class should be merged with the other class. So we have to develop the modified classes to apply the chi-squared test. Modified classes. So observed frequencies and expected frequencies, and I say class number 1, 2, 3, 4. So first two has been merged. So only the frequencies. So this plus C. And similarly, not from the D cell, it should be from the Q cell. So this should be equal to this frequency plus Q3. The rest of the frequencies should be taken as such. So here it will be equal to this value. So that is the requirement to compute the to evaluate the chi-square calculation. Now in the chi-square calculation, we have to compute the metric, which is due to this equation. Chi-square calculation for our reference. So I compute for every cell. So this should be equal to the observed frequency minus the expected frequency, and we require square of it, and divided by the expected frequency. So this is the calculation by on corresponding elements, and we have to repeat it for all the cells, and then the calculated value of chi-square would be just a summation of it. So I write here chi square value so this value would be equal to sum of this value. So that is the essential meaning of this summation. Individually, I have computed the values. Observed frequency minus expected frequency squared divided by the expected frequency. So we have got a value 0.4551. And now let's compute the tabulated value. This is the calculated value. Square calculation. And here calculate chi squared squared from table, or which is the ideal value. So for this case, we have to define the degrees of freedom and the significance level. So I use the function. I write chi-squared inverse function, and we will be rejecting the area. We will consider the significance region in the right tail. Therefore, we use the right tail inverse function. So I write right tail, the probability, the level of significance. So I write here 0.05, and the degrees of freedom. This is important to be computed. So we know that the degrees of freedom are the number of modified classes minus 1 minus the number of parameters computed from the data. So in this case, we have computed 2 parameters. Therefore, the degrees of freedom in this case would be equal to 1. So we have got the value 3.8415, which is a higher value than our calculated value. Therefore, this should be interpreted. If we look at the graphic of that, okay, so the calculated value is less than the critical value suggested by the ideal chi-square distribution. Therefore, we can say that our data is reasonably close to a normal distribution with the parameters mu and sigma. So similar analysis can be performed for other distributions. So just for as a matter of summary, if I unhide the columns, so this was the whole scheme of calculations. From the data, we computed the model parameters mu and sigma from their expressions. So from the data in which the weights were given in their classes and the frequency, so mu was computed, sigma was computed, and then we computed the normal distribution probabilities by transforming the lower limits and the upper limits to corresponding z values, and we computed the probabilities. This can be done using either by table or in software like Microsoft Excel or other. You can use the functions available to compute that integral numerically and get the probabilities. And then we computed the modified. We first computed the expected frequencies, and then we computed the modified classes, where the merger of classes were required when the frequency in expected table is less than 5. So in our case, we have to merge the first 2 classes. So modified number of classes were 4, and then we computed the chi-square metric, which is marked by this equation. Observed frequency minus expected frequency squared divided by expected frequency. Here is this calculation. Square calculation. So it is summation was performed, and then we have to compare the calculated value and the ideal value. The ideal value should be computed at particular degrees of freedom marked by our calculation, and then we make the inference.